All right. So here we are again. All right. Now, yeah, I was just updating this thing and it was taking a while. So I'm going to tell it to stop messing around. Oh, it's off. All right. Yeah, I don't want it to suddenly start rebooting right in the middle of the class because you never know with Windows updates. It might just do exactly that. So, all right, it looks like it's safe. All right, so let's get back to where we were. Now, I saved something very important for today. And so you'll see what it is in a second. Let me get the slides back open. So we're still in the middle of chapter 4. Oh, you know what that reminds me? I almost forgot. We're supposed to go over the chapter 3 problem set. So let's quickly do that. And then we can get back to chapter 4. Yeah, we did have a chapter 3 problem set. It's very quick. It won't take that long, but we need to do it. Here it is. Okay, so we're given a production possibilities schedule, which you can draw and turn into a production possibilities frontier. Now, the idea here is you're really just being asked to sketch it. You're not being asked to turn it into an artistic masterpiece, but you just want to get a rough idea of how this works. Okay, whoops, hold on. Let me do this. All right. So basically what's happening is that, and by the way, it does tell you to put hamburger on the vertical axis and steak goes on the horizontal axis. In other words, what they're saying here is to do this. Whoops, hold on. So it would end up looking, let's say, something like this. Okay. Here's H, hamburger, steak. And so we can pick some of the extreme points here. For example, point A means 20 hamburgers and no steaks. That would be, let's say, here. And then if you move down to point B, you'll have 18 and 2. So let's say that's right about here. And oh, you know, we should label these. This is A, this is B. Now, what we could also do is go to the other extreme, where point E, you have 0 hamburgers and 8 steaks. So let's say that that's going to bring you right about here. It might be easier to do it this way. It's not easy to draw by hand, of course, but we can give it a shot. Now, point C means 14 burgers and 4 steaks, which should be somewhere in this neighborhood. And then finally, point D is 8 hamburgers and 6 steaks. Okay. I figure it's right about here. If we needed to be more exact than this, of course, we would never do it by hand. But the idea is that you can see how it goes from the upper left-hand corner where we have only hamburgers. And in the bottom right-hand corner, we have only steaks. And then we have everything in between. And the curve is convex to the origin. Concave, sorry, it's concave to the origin, which means that the opportunity costs of moving down the curve or up the curve are increasing as we try to make more of one of the two products. And we'll see that when we do the actual calculations. So let's do this. First, oh, sorry, I missed the chats. Oh, I see. Okay, so two people are in together, audio problems. All right. If you can't fix it, you can certainly watch the recording. Do what you can, but remember, all of these recordings are in my YouTube account, and you can find them very quickly and easily. And in fact, just in case you haven't seen them, let me quickly show you where they are to be found. Oh, you did? All right. Well, all right. I'll tell you what, I'm going to show it to you anyway. So if you go, everyone knows YouTube, of course. It's not like anyone here has ever never used YouTube, but you might not realize where my material is. So now I'm not a very sophisticated YouTube user. It's sitting there with my name on it. I mean, I don't know if that's normal or not, but it works. Okay. So if you can't find, you can type my name, and that should bring you to my page, I believe. Yeah, there it is. And you can click this one on. And now you see there's a bunch of videos here, but what you want to do is look at the playlist, because that's where only our stuff is. And then you can see I have a few playlists. This is us. And just click it on. And there you go. So this is only our material. Now, you certainly can feel free to look at anything you want on my website. I mean, I don't care. It's there's school stuff here. There's things, I guess you can look at my liked videos too. I don't know how that works. But my liked videos are mainly, music videos. And like here, you can see there's a video about making meatballs and things like that are in there. So, if you're able to see them, I don't know if you can or you can't. It's okay with me. Oh, no, it does say private. All right. But there's nothing here that you're not allowed to look at. Let's put it that way. Unless YouTube stops you. Okay, so the rest of this is almost exclusively class notes, but you never know. You might decide, I want to look at these other ones. I want to see what's going on in those classes, and you're certainly can feel free to do so. But all right, anyway, so that's how that works. And so anyway, let's get back to this. Now, how do you calculate an opportunity cost? Well, the idea here is that when you're calculating an opportunity cost, it's understood that you're moving between two different points on this production possibilities frontier. So we'll start with in the upper left-hand corner. Now, keep in mind that when you start in the upper left-hand corner, what you're actually doing as you go down the curve is, now, by the way, I just realized they want the opportunity cost of producing hamburger. So that means we really need to start at the bottom right-hand corner, because we want to start where there's no hamburger at all. So we'll start at E, okay? And at point E, I'll remind you here that we have 0 hamburgers. In fact, I'll tell you what, let's do this as a convention. We'll do 0H and 8S. It's understood that 0 is H is hamburgers and S is steaks. Moving to point D. At point D, you can see you've got 8 hamburgers and 6 steaks. So exactly how do you calculate the opportunity cost of the hamburgers? So the opportunity cost of hamburgers is the ratio of sacrificed steaks to the gained hamburgers. Okay, so an opportunity cost is always calculated as a ratio of what did you give up and what did you gain. Okay, so to go from E to D, you can see that in the process, we gave up 2 steaks and we picked up 8 hamburgers. So you can call this a quarter or 0.25. And what that means is each additional hamburger required the sacrifice of a quarter of a steak. So that wasn't much of an opportunity cost. But now, yes, go ahead, Haley.
Why are we starting at point E at the bottom?
Oh, because we're trying to calculate the opportunity cost of producing hamburgers. And that means that we have to go in a direction where we're making more hamburgers. and giving up steaks. Okay, so that's why we start down there, because if we're at A, we can't make any more hamburgers. So we want to start at E because this is the point where we can now make more burgers. But in order to do that, we have to give up steaks.
Okay.
And then we have Fernando, I believe. Yes, I see your hand.
Yeah, just to that, since that's the case, every time when it comes to like these type of graphs, we should always start from the lowest. So
No,
always,
no. I'm only starting here because question B specifically says calculate the opportunity cost.
so just okay, so it depends on the question.
Yes.
Okay.
Now in part
All right, thank
C, it asks about steak, and we're going to go from A down to E. Okay, so the direction you go depends on which good they're asking about. All right, so if they're asking about the good on the vertical axis, then you're going to start in the bottom right-hand corner and move to the left. If they're asking about this good, the steaks, you're going the other way around. Okay, Mills, go ahead.
Yeah, so just to clarify, if you're looking for the opportunity cost of the hamburgers, you want the hamburgers to be the denominator in that
Yes.
equation, right?
That's exactly right. Exactly.
Okay,
It
thank
always
you.
works that way. Whatever you're losing goes in the numerator, and what you're gaining goes in the denominator. Yes, and that never changes. Exactly. So now let's go from D to E. Sorry, D to C. So again, you have to visualize that you're going from one point to the next. So in other words, we're making 8 hamburgers now and 6 steaks, but for whatever reason, the customers are not asking for steaks. They're asking for hamburgers. So we have to stop making so many steaks and make more hamburgers to satisfy the customers. So at point C, we have 14 hamburgers and 4 steaks. So now, in order to calculate this, and of course, this part doesn't change, this formula. But what's different now is that when I go from D to C, if you notice from D to C, I only gained 6 hamburgers and I lost 2 steaks. So the 2 in the numerator hasn't changed, but the denominator is only 6. Okay, so this time when I sacrificed 2 steaks, I only gained 6 burgers. And so my opportunity cost is 0.33, which is higher than 0.25. So as I keep going up the curve, my opportunity costs will keep getting steeper and steeper, or higher and higher. Okay. Now, from C to B, so we'll say moving to point B. At point B, you can look at the chart or the graph. You have 18 burgers and 2 steaks. So you see what's happening here. The way this table was constructed, and it doesn't have to work this way, each movement entails the loss of the same amount of steaks. What's happening to the burgers, though, is that each extra steak that we lose is only providing us with fewer and fewer extra hamburgers. Now, why is this happening, by the way? Because if you look at the cattle, where this is coming from, the meat that produces steak and hamburger, it's not exactly the same. They're not quite the same. They're not perfect substitutes for each other. So as you try to make more and more burgers, there's less and less of that type of meat available. And more steak is just sitting there not being used. So it becomes less and less efficient to make more and more hamburgers. Okay. So what happened here, the ratio, and again, you notice we've lost 2 steaks, but we've only gained this time 4 burgers. So the ratio becomes 2 to 4, which is a half. And that means it continues to rise. The opportunity costs will keep going up. And then finally, when we try to make only burgers and no steaks, moving to A, at point A, we have 20 burgers and no steaks. Man, so the opportunity cost is really getting steep.
I have a question.
Yes, go ahead.
Why, like it says moving to point B, it says 18H and 2F, right?
That's correct, right here.
So then how did you get 2 fourths then?
Oh, all right. Well, what you have to do is compare that to point C. In other words, you're always comparing it to the previous point. So like at moving to point B means you can see I've highlighted the two lines. As I moved to B from C, I picked up 4 burgers, but you can see I lost 2 steaks.
Okay.
That's what it means. Okay, so we're always comparing that point to the previous one when you calculate these numbers. All right, does that make sense? And now from B to A, you can see I gained 2 burgers and I lost 2 steaks. So therefore, this is now up to 1. So each steak, each new hamburger requires me to give up a full steak. So you're giving up more and more steaks to get hamburgers as you go up the curve. Now, what that usually means in practice is that unless the price of the hamburger suddenly goes up through the roof, you may not want to produce at point A or even point B. The place you ultimately choose to produce at will depend on a lot of factors, but ultimately it'll depend on how much you can sell the hamburger for versus how much you can sell the steak for. So, the customers make these decisions, how much do they want to buy? But as far as production goes, to make more burgers, we have to be prepared to give up progressively more steaks. And so that's why there's going to come a point where most likely it won't make sense to go any further. Now, we won't know where they'll choose to produce without more information, but we do know that we are incurring increasing opportunity costs to make more hamburgers. So, if the customers want more hamburgers, that's fine, but they'll have to pay more for them. And that's just the way it works. Okay, that's just, you want more of something, you have to pay for it. Now we're going to go in the opposite direction. We want the opportunity cost of producing steak. All right, so we're going to start in the upper left-hand corner. We start at point A. We're going in the opposite direction, because now what we're trying to do is see what happens as we make more steak and less hamburgers. Okay, so the opportunity cost of steak requires us to know how much steak we're gaining and how much hamburger we're losing. So we have to go in the opposite direction from the upper left-hand corner to the bottom right. So start at A, and at A, we have 20 hamburgers and no steaks. And then when we move to B, so B, remember, was 18 and 2. So now here's the important detail. This opportunity cost will actually be the inverse of what we had here. So in other words, the opportunity cost of steak is the sacrificed hamburgers over the gained steaks. And so you see what happened here. We gave up 2 burgers to pick up 2 steaks. So here the opportunity cost is 1 to 1. Then moving to point C. Let's go back up here. I don't know what happened. I lost my split. It's really annoying to have to go back and forth all the time. So I'm going to split the screen. Yes. Oops. There we go. There we go. Okay. So point C, if you recall, is where we have 14 hamburgers and 4 steaks. So now what we've just done as we go from B to C is we have lost 4 hamburgers this time in exchange for gaining 2 more steaks. So all of a sudden, the opportunity cost is 2 instead of just 1. So already you can see it's going up. As we go from A to B, the opportunity cost is 1. From B to C, it goes up to 2. And it will continue to rise because of the shape of the production possibilities frontier. So at D, we have 8 hamburgers with 6 steaks. Oh, this was supposed to be an S, sorry. I just want to be consistent here. So therefore, we're going to find that this time from C to D, we sacrifice 6 burgers to pick up 2 more steaks. And that's going to give us a ratio of 3 to 1, or just 3. So just as we predicted, the opportunity cost is rising. And then finally, we'll move from D to E. And at point E, or actually, okay, I'll just leave it like this, just to be consistent. At point E, we have no hamburgers and we have 8 steaks. So compared to what we had before, we've gone from 8 hamburgers to none, which is, we lost 8 burgers to pick up 2 more steaks because we went from 6 to 8. So that ratio suddenly climbs to 4 to 1. So it's getting very expensive to make these steaks, isn't it? We're giving up an awful lot of burgers that we could have sold to the customers. So if we're going to keep making more and more steaks, we're going to have to charge a progressively higher price to compensate us for the loss of burgers. So the restaurant may say, you want more steaks, they're going to go up in price. And what's interesting enough, sometimes restaurants will do, especially if you've ever been to anywhere in New England, where seafood is extremely popular. But, the thing about seafood, the supply of beef is pretty predictable. I mean, it takes a while to raise beef cattle, but it shouldn't be that difficult to tell how much is available because, like I said, it's a very long process. Seafood is different. It depends on what was caught that day. So if you're in New England, most likely any seafood you eat in a restaurant was probably caught in those waters probably that day. The problem is you can't tell from one day to the next how much will be available. You don't know how many lobsters you'll have or how much salmon or any of the others. So what they do on the menu is they don't put a price, they call it market price. And that way they can adjust it. So like if there's not so many lobsters available today, they jack up the price. If there's a lot of lobsters, then they can lower the price. Most of the time, though, they have a fixed number sitting there. But even then, if they find that consistently people are asking for more and more steaks, at some point they'll have to raise the price because, again, they're giving up the opportunity to sell all these hamburgers. Okay. So, all right. Anyway, so that's all we had to do here. They just really wanted you to calculate or draw the picture and do all the calculations. If you can do these, you can do any case that comes along. Fernando.
Yeah, I have a quick question. I
Right.
noticed that when we moved from hamburgers to steaks to hamburgers,
Yes.
I noticed that the opportunity rate is different. Like one
Yes.
is like rising up in a whole number, and the other one's just I guess like either rising or decreasing in the decimal.
That's right. Yes,
That's
because
why.
what's happening is in one case it's the numerator that's changing, and in the other case it's the denominator that's changing. So like the area between B and C for the hamburgers, that's a half. But if you're looking at the steak, it's 2. Okay. So in other words, the two are always inverses of each other. If one is 4, the other is a quarter. So that's one of the interesting features about the way this is set up. Now, if we had a straight line, though, then the opportunity cost would always be the same, no matter where we are on the point. In fact, maybe we'll do an example of that later on when we're practicing for the test. We'll have an example with a straight line, and you'll see that no matter where you are, the opportunity cost of both goods is always exactly the same. So it's kind of like, I think I mentioned this example once before about sleeping and non-sleeping. You only have 24 hours a day. So every hour that you sleep is the opportunity cost of an hour of doing something else. And that never changes because you only get 24 hours. It's not possible, let's say, for example, to be more efficient and suddenly have more time. Well, not really. I mean, the time itself is fixed. All right. Well, anyway, so I'll be posting this on Moodle as usual, and then you can look at it if you're not sure. And you can still ask questions, anytime you need to, and say, listen, let's go over this again, and we will. But right now, let's get back to supply and demand, okay? So anyway, but we did see last time how important this is, especially in an area like international trade, because instead of two goods between two producers or one producer, we're looking at two countries, and we're trying to understand how and why they trade with each other. Jeremy, yes.
Yeah, I was wondering, when is going to be our first quiz or like exam?
Oh, well, we're not really having quizzes as such. Basically, we're going to have practice problems like this, and we'll have some review sets for the exams. And then the exams themselves you'll be doing at home. And you'll have access to your notes and your slides and the videos and all the rest. But you can think of them as take-home exams.
Oh, so like midterms and like the final exam, that's it?
There's 2 midterms and a final. Yes, that's all you have to worry about.
Okay.
The rest of it, like this one, was just meant, as you can see, just to get some practice and understand the concepts better. But also keep in mind, this is going to be on the first test. So when you do this, you're actually getting ready for the exam. You're like basically putting a down payment on your studying time. Okay, because the tests will be very, very similar to these problem sets. Okay, there will be no surprises.
You can always get an early one too.
I'm sure you've had classes where there were surprises. I don't appreciate surprises either, so there won't be any surprises. Okay, so you don't have to worry about that. Okay, all right, let's get back to it. Now, supply and demand. Now, remember, this is the underlying, everything in economics ultimately comes down to supply and demand, right? Just about everything. So this is an incredibly important concept. And by the way, when chapter 4 is done, starting in 5, we're going to move off in a very different direction. We're going to be doing nothing but macro. Up to this point, what we've been doing is the content that's common to both micro and macro. After that, it's going to be 100% macro, and you'll notice the difference, because a lot of those concepts, you'll realize you've heard of them before, you've seen them in the news. And so a lot of macro concepts are what are constantly talked about in the news. Micro, not so much. Micro is a very specialized field, but it doesn't tend to get itself into the news a lot. Let's put it that way. Like, when was the last time you saw a news story about opportunity costs? Well, it doesn't happen, does it? But you might have seen in the news that gross domestic product is growing or shrinking or whatever, or inflation is rising or falling. So we'll be focusing on those types of topics. But right now, we're still laying the foundations for what comes afterwards. Now, back to this. Now, we were last time looking at supply and demand. Now, remember, there's several factors that determine the demand for a product. But ultimately, the bottom line is that our demand for a product can be expressed with a demand curve. And that, in turn, as we saw, is downward sloping. Now, that applies whether this is the demand from a single individual or the entire market. We can do both, all right? So this one is the entire market. You can tell because the quantity is in millions. This is the market for pizza in the entire country. For an individual, there wouldn't be millions here, would there? No. You would have a small demand curve, and it shows us how much we're willing to pay for each quantity of pizzas. And clearly, we're not willing to buy as many pizzas if they're very expensive. But if they're very cheap, we're going to buy more pizzas. Okay, so imagine yourself every day needing to buy lunch, and you'd say to yourself, what should I have for lunch? And let's say some days you have burgers, some days you have fried chicken, some days you have, maybe you have a healthy salad once in a while. You never know. But if pizzas get unusually cheap, most likely you'll find yourself eating pizza more often and all the rest less often. Okay, so that's what this is all about. Now, supply comes from the producers, and it shows us how much they're willing to produce for every given price. Now, since they're trying to make money, their job is to make a profit. The higher the price of any good, the more the producers are willing to produce. So like if you're running a pizzeria, let's say that you have, even a pizzeria has other things to choose from too. It's not just pizza. They've got like meatball subs, and they have chicken parm, and they have all this and that. But if pizza prices keep rising, they're going to spend as much time as possible making pizzas and not so much time making the lasagnas and the meatball subs. So because they want to make a buck, you know, they're trying to make money. So they will focus their attention on producing whatever it is has the highest market price. That's how they make their profits. So the supply curve is upward sloping because at higher prices, more of the good will be produced. Now, this is where we left off, and I did this on purpose because this is such an important topic that I don't want to just rush through it. We're going to see a very interesting word here. It's called equilibrium. And it's obviously a Latin word. It means that something is in balance. There's a balance between two forces or two factors. And in our case, it means that the quantity supplied of a good is exactly equal to the quantity demanded, which means that the amount of a product that people want to buy is exactly the amount that's being produced. So that means everyone's happy. Now, how does this happen, or how do we show this? We have to bring the two curves together. And look what happens, because they have different slopes. Oh, first I've got the charts. In other words, the second column is the demand schedule, and the third column is the supply schedule. We've already seen these, but now it's pretty obvious that there's only one place where they equal each other, and that's when the price is $10. So if the price is 10, people are willing to buy 5 million pizzas, and the producers are willing to produce 5 million pizzas. So everybody's happy. And the fact, here's what that looks like. You can see the two curves cross at one point. Because they have different slopes, they have to cross it at one point, and that point is what we mean by equilibrium. And you can see that here's the price, and here's the quantity. And this is where everybody's happy. So this is an incredibly important concept in economics. This is like almost all analysis we do in economics has something to do with equilibrium. Okay, so that's the point where the markets are in balance. Now, you might have seen this word equilibrium in high school in some of your science classes, but it meant something a little bit different there. But the idea of a balance is always present with this word. Like in physics, it might mean a balance between two forces, or in chemistry, it might mean a liquid that's stable. You know, you've mixed together some different chemicals and they're stable now. And so we're said to be in equilibrium. In fact, I remember an example from high school chemistry, but they pointed out to us something interesting one day. They said that if you took a beaker of water and you started stirring sugar into it, the water would absorb the sugar up to a point. And then after that, the excess sugar would start to settle to the bottom of the beaker. So when you reach the exact point where the water is saturated with sugar and it can't hold anymore, you've reached equilibrium. So that's an example that occurred to me from high school chemistry. But here it's just the equality between quantity supplied and quantity demanded. Now, here's an interesting question. Are markets always in equilibrium? Is it possible that something is not right? They're not in balance with each other. For example, what if the pizzerias are charging $6? What's happening? Well, the price is so low that people want to buy a lot more pizza than the pizzerias are willing to produce. That is not equilibrium any longer, is it? That means this is what we call a shortage. There's not enough pizza to go around. But on the other hand, if the pizzerias charge too high a price, like $14, that's the other way around. Oh, Fernando, yes, go ahead.
So wouldn't that mean if it's like they start charging $6, you're scarce your resources are scarce, right?
Yes, they are. And so what that means is people will come into your pizzeria and ask for pizza and you don't have enough. You have to tell them, sorry, we're all out. You don't want that because then you're losing profits. Okay, so we call that a shortage. You notice that sometimes in a supermarket when something is going on sale, you go in the door and you say, well, I'm going to go over there and buy some Coke. And all of a sudden you realize there's no more left. What happened? It was on sale and people scooped it all up before you got there. But then if they, on the other hand, charge too much, $14, a lot of people won't buy the pizzas at such a high price. So they'll find themselves with more pizza than people want to buy. And then they have to throw it out and it goes to waste. So we call this a surplus. There's too much being produced. The price is so high that people aren't willing to buy it all at that price. Now, as it turns out, the producers are, they see this happening. They know what's going on. And if they see that there's a shortage, they'll say to themselves, listen, why are we charging such a low price? If people want so much pizza, why don't we just raise the price and see what happens? And guess what happens? Gradually, they move it up to the equilibrium level. And now we've achieved our balance again between quantity supplied and quantity demanded. But on the other hand, if the price is too high and they realize they've got too much pizza on their hands, they can start cutting the price. And gradually, we find ourselves once again back at equilibrium. So we're assuming in economics that if we're not in equilibrium, there's an automatic tendency for prices to adjust to bring us back to that equilibrium level, because the producers have a very powerful incentive to keep the price where we have an equilibrium. And if they see that it's not there, they'll make whatever adjustments are needed until we find ourselves back at equilibrium. In fact, when you see things go on sale in supermarkets, the reason is because they have too much. The supply is greater than let's say you're down here. Let's say you're charging too much for cans of soup, and it starts piling up in the shelves. You put it on sale, and that takes care of the problem. So you know that when something goes on sale, most likely they had too much of it, and they're trying to get rid of it. And so you walk in and say, oh, that's not a problem. I'll buy everything you have here. I want it. So I'll take it at the lower price, please. Anyway. So when a market is not in equilibrium, so the price is below the equilibrium price, the quantity demanded will exceed the quantity supplied, and we call that a shortage. And if you forget which is which, just think about it like from the perspective of a consumer. If the pizzas are normally $10 and the price suddenly goes down, your reaction would be naturally to buy more. But of course, if everybody reacts the same way, suddenly there won't be enough pizzas around. The producers have to increase their output in that case. Otherwise, we end up with a shortage. Okay, but once there is a shortage, the price will go back up because the producer understands what's happening. And in the meantime, people start buying progressively less of the pizza, more is being produced, and eventually all these adjustments will stop once we reach equilibrium, because then there's no reason for it to change any further. Now, if the price is too low, like 6, like I already mentioned, then there's a surplus. By the way, you can calculate the size of the surplus by looking at the difference between these two. I'm sorry, shortage, not a surplus, shortage. 4 million. Okay, how do you know? Because that's 7 minus 3. That's how many extra units of pizza people would like to buy, but it's simply not available. And so the price will continuously rise until it reaches $10 when we're back in equilibrium. Oh, and by the way, that would look like this. So in other words, here, imagine here's your graph. The equilibrium price is 10, but we're charging 6. The shortage is the vertical or horizontal distance between these 2 points. QD is 7. QS is 3. QS, the difference is 4, and that is a shortage because that's where people want to buy more pizza than is available. Okay. And then, of course, we know that the opposite could happen. The price could be too high. And, sometimes the manufacturer of a good doesn't really know exactly what the right price is. Sometimes they have to do experiments to see what the equilibrium price is. Unless they have the ability to do a lot of market research, when a new product is released, especially, it may take time before the producer can figure out the equilibrium price. So there might be a lot of adjustments. And in fact, if you notice, like a chain like McDonald's, what they'll often do is they'll experiment with prices in different markets. They'll raise it, they'll lower it, just to see how people react to it. But not every McDonald's charges the same prices, of course. But they have to really be on top of this because it's a very competitive market. And they don't want Wendy's and Burger King to take away all their customers. So one of their strategies is not to so much juggle the prices of the goods themselves, but create different bundles, which enable people to get what they want at probably reasonable prices. But the outcome of that is that people tend to buy more food that way, because if you're buying 3 things instead of 1, it may seem like a bargain, but you're still spending more money. And McDonald's is happy because their sales go up. So yeah, they know what they're doing. All right. But anyway, if the price goes up too high, they'll suddenly discover, hey, we're not selling all the products that we're producing. We've got more than we need. You go to the grocery store and they've got too many cans of corn sitting there. That means it's time to put them on sale. There's a surplus. So let me just show you the graph real fast. Here's the surplus. So if the price is 12 for the pizzas, the quantity supplied here is 6. The quantity demanded is only 4. And so all of a sudden, the quantity supplied minus the quantity demanded is 2. So you have a surplus of 2 million pizzas. Okay. Anyway, and again, what they will do is they will certainly lower the price because they recognize that they're producing too much pizza. People aren't willing to pay that much for it, so they cut the price, and eventually we find ourselves back at equilibrium. Okay, now, what we want to do now is consider what happens if there's a change in one of these many factors that determines the demand or the supply for a good. Now, remember, we identified 6 different factors that affect the demand for a good. And I think it was 4 or 5 for supply. I don't remember how many, but here it is. It was 6. Okay. So the question is, what happens if one of these changes? Okay. What if, for example, consumers' taste for good start to increase or decrease? How does that affect our equilibrium price and quantity? Good question. It has to have some impact. If we suddenly decide that we want more chicken than ever before because it's healthy, that has to influence the price that we pay for it and how much we can have. It also may influence how much is being produced. So how do we show that? Well, we'll start with demand. And what we'll do is show what happens when one of those 6 factors changes. And let's see, here it is. Change. Oh, okay. Now, before we do that, though, there's one important concept that we have to understand very, very well. There's 2 things that can happen with a demand curve as far as changes are concerned. Let me see if I can sneak one in here. Oh, here it is. Imagine here's the demand curve for a product. This is the pizza. We're just looking at the demand curve. Suppose the pizzeria, like I said before, they've got too much pizza being made, and they're only selling 4 million pizzas. Okay, then they come to their senses and they lower the price to 10. As a result, the quantity demanded goes up to 5. So what we would call this is a change in quantity demanded. And that is represented by a movement along the demand curve. Now, what's important here is that none of the 6 factors have changed. The only thing that's different is the price that's being charged. So therefore, we are going to move up and down this demand curve, and we call that the change in quantity demanded. And it can go both ways, of course. The price can go up and it can go down, but we're staying on the same curve, and that's the key detail. Our desire to buy this product hasn't changed. The other factors haven't changed, only the price. But what if one of the 6 factors does change? That's what we want to get to. That's the one we want to consider right now. When that happens, we call it something almost the same, but you can see there's a subtle difference here. Be careful with this. It's not called a change in quantity demanded. We now call it a change in demand. And that's because the entire relationship has been affected somehow. Oh, yes, go ahead.
Oh, so are you saying that the reason why it's called a change in demand is because the buying plans changed?
Yes, this is a result of one of the 6 factors has changed. For example, tastes. So there's something different now about our desire to buy this product. Like I said, organic foods, let's say. Over time, the demand for organic foods has increased because people are more and more aware of its health benefits. So that is one of the 6 factors. And by changing that, the entire relationship between price and quantity has changed. And so instead of having a movement up and down the same curve, the impact will be the entire curve will move. That's the key difference now. So with change in quantity demanded, the price of the good changes, but nothing else. And so the result is that we move up and down the same curve. But now something different has happened. One of our 6 factors has changed. So the entire relationship is different now. So the curve can shift in 2 different directions. It can go to the left. And if it does, let me just quickly sketch that in here for you. Let's say that the demand curve was here. I'll call it D1. And now it suddenly shifts over here to D2. That means people want this product less than they used to. This could be, for example, tobacco. Because as you know, tobacco consumption has shrunk in the US quite a bit, as a matter of fact, over the last few decades. So this is defined as a decrease in demand. Okay. So that's because people want less of this good. They're less willing to pay for it. Their tastes have declined, or maybe their incomes have declined. There could be a lot of reasons for this, but the bottom line is they're not willing to pay for this good as much as they used to. Fernando?
So within changing demand could impact the outcome of the product for like the company.
Yes, it'll affect the equilibrium price and quantity, as we'll see in a few minutes. But
Okay.
if, like, for example, you can be sure that the tobacco companies are not making as many cigarettes as they used to because people aren't buying them. People, you don't keep making something that people won't buy. And there's a lot of products where this happens. Sometimes technology makes something obsolete and people buy less of it. like, well, for the longest time, like LPs, suddenly they're making a comeback all of a sudden. So the demand is shifting back to the right. But when CDs came along, LPs more or less disappeared for the longest time. And now suddenly people are being nostalgic and buying them again. But when something happens that causes us to want less of a good, then the demand curve shifts to the left, because we're willing to pay less money to buy the same quantity of the product. Whereas if it's the other way around, let's say there's some new exciting product out there. Let's say a new energy drink comes into the market, and it turns out that the energy drink actually helps you lose weight. Well, you know what? People are going to want to buy more of it. They're going to say, oh my God, I just have to drink this energy drink and I start to lose weight. Or maybe it's just cool. Maybe a new product is invented, or maybe an existing product is improved. But if we want more of this product, like organic foods, we call this an increase in demand. And so both of these are collectively known as a change in demand. So in other words, there's two ways of having a change in demand. Let me put that up here as the label on top. Change in demand can come in two different forms, a decrease or an increase. And keep in mind that this is caused by a change in some factor, one of the six, that is, that influences demand. All right, so let me just type up a quick summary here. Okay, so in other words, if the price of a good changes, there is a movement along the same demand curve. This is known as a change in quantity demanded. If any other factor, really, in principle, any other factor, but if any of the determinants of demand changes, the entire demand curve shifts. This is known as a change in demand. Okay, so it gets the idea that the entire relationship between what you're willing to pay for a good and how much you buy has changed somehow. So we want to get some practice here drawing pictures of these two cases. So just remember, the price moving, this is change in quantity demanded. Outside factors means a change in demand. So like, for example, imagine that with the pizza case, suppose that pizza is a normal good and people suddenly have more income, they have more money to spend. In this example, I'm assuming that at every price, people are willing to buy 2 million more pizzas than they were before. Okay, now maybe that's an exaggeration, I don't know, but let's just say that because we perceive pizza as being a normal good, the fact that we have more money in our pockets means we'll buy more pizza. So you can imagine that the entire demand curve, in order to reflect this change, will shift to the right. It's parallel to the original curve, but it's shifted to the right by 2 million pizzas. Okay, so let's say before, at a price of $10, we were willing to buy 5 million pizzas. Oops, I haven't drawn this very well. Let's all right, let's do it here. Let's say 10. Here's 5. And now at the same price, they're willing to buy 7 million pizzas. So this, I hope this helps you see that what's actually happening here is that for every possible price, we're going to be willing to buy more pizzas than we were previously, by exactly 2 million. So this is an increase in demand. And also this gives us an opportunity to see in economics, just in general terms, whenever there's been an increase in some factor or other, the curve that we're using to illustrate it will typically shift to the right. To the right will be used to indicate an increase in something. The left will indicate there's been a decrease. All right, so you'll see, we'll get more and more practice with curves and you'll see that that's how it works. And, you know, it doesn't really matter why this happened. As long as there's been an increase in demand for some reason, this is the net effect. The entire curve shifts to the right. But on the other hand, what if there's a recession? People's incomes are dropping. Well, you can see what's going to happen. Let's say now the opposite happens. Before, when we had $10 for the pizza, people were willing to buy 5. Now they're only willing to buy 3. The curve is shifted to the left by 2 million pizzas because of the recession. People's incomes are falling. They're concerned. They don't want to spend quite so much money on pizzas. So therefore, yeah, what they'll do is they'll stay at home and cook for themselves, or, you know, something like that. Cook something cheap, that is. And so the demand shifts to the left. The demand curve will shift to the left again by 2 million. So just imagine that at a price of 10, before we were buying 5 million pizzas, now we're only buying 3. So we call this a decrease in demand. And it can be caused by a lot of reasons, but the bottom line is we're buying less pizzas at every price. All right. Or, you know, there's so many possibilities. What happens if the government announces one day that, you know what, pizza actually has twice as many calories as we originally thought? Well, pizza people will say, uh-oh, I don't want to get too chunky here, so I'll buy less pizzas and buy more vegetables or something. So anything could cause this. What if, for example, people's tastes just change? They do change over time. Although it's hard for me to imagine the demand for pizza ever being different. But still, you know, for some products, like I've mentioned, organic goods, the demand can change. We know about cigarettes. What else? I can't think of any other good examples off the top of my head, but there's certain products that people simply buy less of because their tastes are different. Now, what does this do to our equilibrium? Aha. So what I'm going to do is show you, rather than having you memorize this chart here, let me just show you. So what I did here was I took the original supply and demand schedules and I've introduced, well, actually, no, sorry. This is the new demand curve that resulted from an increase in the demand for pizza. Not the original one, but the new one. All the numbers are 2 higher than they used to be. And so now all of a sudden, look what happens. The equilibrium price is higher. It's 12 instead of 10. And the equilibrium quantity is higher as well, 6 instead of 5. So because people want more pizza, they're not only willing to pay, well, they can have more pizza. You can see the quantity went up, but they have to be prepared to pay more for it. Okay, so that's what this is all about. And I think you'll see this more clearly when I show you the graph. The demand curve shifted to the right. And so with no change in the supply curve, they cross at a point E2 instead of E1. And now all of a sudden, the price is higher, but so is the quantity. So an increase in demand has 2 impacts. Equilibrium price rises. Equilibrium quantity also rises. Okay. And you can tell, if you forget, just draw the picture. Just find out where the new intersection point and you're all set. Yes, Fernando.
That surplus line, could you also explain why is it like, increasing towards the demands?
Well, no, we're assuming that we're in equilibrium. There's no surplus right now. We started with an equilibrium of $10 and we bought 5 million pizzas. And now because people want more pizza, the demand shifts to the right and the new equilibrium is $12 and 6 million pizzas. So we want more pizzas. Let's say our incomes went up, we want more pizzas. Now the supply hasn't changed. The ability of the pizzerias to produce pizza hasn't changed. So we can do this. But imagine all the pizzerias, what do they have to do to make more pizzas? They have to buy more supplies, they have to hire more workers, they have to stay open later hours. So their cost of production will start to go up. So they're happy to sell more pizzas, but they have to get a higher price to compensate them for their higher increased expenses. But the people who want more pizza will say, well, whatever, I have the money. My income went up. I'm willing to pay $12 now instead of 10. And so more people will have pizza, but they have to pay a higher price.
Oh, okay. Then what would that S in that line of that S represent then? Just
S is the supply curve. That hasn't changed.
supply curve, okay.
Yeah, we always have to have both the supply and demand curve in these diagrams. We can move them around, but we have to have them both. So S is just the original supply curve, only the demand is changing in this example. All right, so yeah, I mean, it's like any business. All of a sudden, the demand for your product goes up. You're going to want to sell more units, but your costs will go up most likely. So you'll have to raise your price, but you still can sell more units at the higher price. And that's how it works, like anything else. The more we want something, the more the price goes up because the cost of production go up. Now, if you can imagine the case, remember we said before that the demand for pizza could fall if our incomes fall. Let's see how that impacts the equilibrium now. And you could probably guess it's just going to be the opposite. Okay, so now what I've done is I've introduced the demand curve where our demand for pizza is lower than originally. And now all of a sudden, the new equilibrium price is only 8. And at that price, $4, we're buying 4 million pizzas instead of 5. So the pizzerias are saying, well, people don't want as much pizza as they used to, so we're going to make less of it. And we'll switch, some of our resources to other things like I said, chicken parm sandwiches and meatball subs and stuff like that. And so we're going to sell less pizzas and we'll charge a lower price because people don't want it as much as they used to. If we kept the price at 10, we would have a surplus. So the curve shifts to the left and we have a decrease in demand. And that leads to 2 consequences. The equilibrium price goes down. But the equilibrium price also falls. The equilibrium quantity. They both are falling. Okay, you can tell we went from $10 and 5 million pizzas to only $8 and only 4 million pizzas. And this is just exactly the opposite of what we saw when the demand increased. And you might remember before, I did mention that a decrease will typically be illustrated by a shift of a curve to the left. And that's what we're seeing here. Very good. Now, what have we not considered yet? What about supply? Can the supply change? Of course it can. So again, we have to make an important distinction between 2 basic concepts. So remember before we had a price change and we call that a change in quantity demanded. Similarly, here we have a change in quantity supplied. Because we're just moving up and down the same curve. This is caused by a change in the price of the good. And we can go either up or down. Here it just so happens the price was reduced and therefore the quantity supplied drops. So the quantity supplied drops due to a price reduction. So nothing else has changed. It's just the price. So we call this a change in quantity supplied. And so you can probably guess that just like with demand, if anything else changes, if any of those external factors changes, the entire supply curve will move somehow. Okay, so, and you're absolutely right. Okay, so change in quantity supplied means we move up and down the curve, whereas a change in supply means the entire curve is shifting. Okay. So let me show you those two cases. By the way, you should get some practice drawing this yourself because you may have to do this on an exam. So if the supply curve increases or shifts to the right, we call this an increase in supply. And of course, if it goes the opposite way, and again, there can be a lot of reasons for this. We have a decrease in supply. Both of these are collectively known as a change in supply. All right, so just like with demand, there's two different ways it can change. There's an increase and there's a decrease. And again, if you notice, an increase is indicated by a rightward shift of the curve, and a decrease is indicated by a leftward shift. Okay, now, so does everyone see the connection between the two? Yes, increase means we shift the curve to the right, decrease means we shift it to the left. Now remember, let me do this real fast. I typed up a nice little summary here for, I'd like to do that for demand. Okay, where is it? Oh, here it is, here it is. Okay, now I've completely lost my place. Oh, here we go, here we go. I just have to change it. So the price of a good changes, there's a movement along the same supply curve. And this is known as a change in quantity supplied, of course. So in fact, it's so similar, all I have to do is change a couple of key words here. If any of the determinants of supply were to change, the entire supply curve shifts. And that's known as a change in supply. Okay, so that's what I wanted to get at here. So it's the same as it was for demand. Change in the price means it's a change in quantity supplied. We go up and down the same curve. A change in supply itself, meaning one of the outside factors, means the entire curve shifts around, and we call that a change in supply. So it's a very subtle distinction between these two, but you just have to get used to it. It's very important. Very good. Now, with all that being said, we want to consider what happens graphically if there is in fact a change in supply. Obviously, it's going to affect the quantity, equilibrium quantity, and the equilibrium price. The question is how. All right, so imagine the following scenario. It costs less to make pizza. Tomatoes suddenly become very cheap. There's been a bumper crop of tomatoes wherever they're coming from, maybe Italy, but possibly just Florida. And so because of that, more pizza will be produced at every price because it's cheaper to make it. The profit per unit is going up. So we'll come back here and we'll show you the original supply curve and the new one. And you notice the new one, at each case, I've added 2 million pizzas to the original supply curve. And so the entire curve has to shift to the right by 2 million. So for example, previously at a price of 10, we were willing to make 5 million pizzas. Actually, let me fix this. Yeah, these are not exactly engineering drawings here. Trying to make it look consistent. I'm not completely succeeding here. All right, the idea here is that we went from 5 to 7 when the price with the same price. So this is an increase in supply due to the cost of production. But on the other hand, what if the the tomatoes become more expensive? There's been frost in Florida. The tomato crop was ruined. And so the cost of tomatoes is going up. And so because of that, it becomes more expensive to make pizza. The profits drop. And so less will be made at every price. So again, here's the original supply curve. I've cut them all down by 2. And so you can probably anticipate what this is going to look like on the graph. The entire supply curve will have to shift to the left by 2 million units. So again, if you had a price of 10, instead of being willing to make 5 million pizzas now, we're only now willing to make 3 million. And so the result is a decrease in supply. Very good. Well, now, so we covered a lot here, but we still have to consider what happens to the equilibrium price and quantity when there is a change in supply. Okay, that's the last part of this. And so again, if you're not sure, you can just draw the picture. Let me show you what this looks like. So what I did was I brought back here, this is the case where the supply goes up by 2 million units. This is the new supply curve. This is the original supply curve. And if you notice something interesting here, the price went down, but the quantity went up. Well, that sounds like fun. This is the opposite of what you saw in the demand curve. When the price went down, so did the demand, but now it's the other way around. So let's look at this curve. Look at that. The price dropped, and yet we still can have more pizzas. I like this one. But again, remember, this is probably caused by an improvement in the ability to produce pizzas. For example, it got cheaper because of the bumper crop in the tomatoes. And so we're basically both benefiting from this. The people who demand the pizzas are getting more pizza at a lower price, while the producers are able to sell more pizza at a higher profit per unit. Even if the price drops, their costs have gone down too. So once again, we have an increase in supply. And look what happens. Both the equilibrium, actually, no, I shouldn't say that. That's not correct. The equilibrium price went down. But the equilibrium quantity rises. So we're really happy. You get to have more of a product at a lower price. Well, how often does that happen in the real world? But this is what causes it. In fact, this is why you can have so many wonderful high-tech products, because technology keeps improving. And so you can have more and more goodies like iPhones and iPads and laptops and all the rest. And the price, if anything, is actually falling. This is why the technology makes it cheaper to produce these goods. And that's why people like Jeff Bezos and Bill Gates and all the rest of the people at Apple are so crazy rich, because they're able to produce goodies that we like at progressively lower prices and with more and more cool features. Okay, so we reward them by giving them our money, and all of a sudden they're crazy rich. All right. Oh, what part are we not getting? Oh, something's going on. Okay. I wasn't sure if somebody had a question. Is there something that anybody's not understanding? We can go over it again. All right. Well, now what happens if the cost of the tomatoes goes up? There's a frost in Florida. The tomato crop is ruined. The cost of making pizza goes up. The supply curve will shift to the left. Okay. So in other words, here's the new supply schedule. I've reduced each one of these numbers by 2. And you can see now, though, this is bad news. Not only did the price go up, but we're getting less pizzas. So we're actually paying more money for less pizza. Now that's bad news for everyone. Wow. Look at that. So this is a decrease in supply. And the result, as you can see, 2 bad things happen. The equilibrium price increased and the quantity decreased. This is exactly the opposite of what we want to see, isn't it? So that's a very bad situation for everyone, because the producer is probably losing. Their profits have probably fallen, and we're getting less of the product at a higher price. But when the cost of production go up, this is exactly what happens. So that's why when we hear things like, the cost of the tomatoes went up because there's damage to the crops, that's bad news for everyone. Or like sometimes in the past, there have been times when sugar prices suddenly went up dramatically, and then the cost of everything you buy that has sugar in it goes up, and it's just, you don't realize it, but that can be very expensive. Okay. So what else is there to discuss? Okay, now, up to this point, all of this discussion was assuming that there's no interferences in these markets. In other words, the markets are completely free to move it as they see fit. Prices and quantities fluctuate with the supply and demand of goods, but sometimes the government steps in and intervenes in these markets. Well, sometimes they have a good reason, sometimes they don't, but if the government suddenly steps in and sets limits on how much a price can go up or down, it has a major impact on all the market participants. Now, we're going to look at 2 cases of government intervention in the market. One of them is called a price ceiling, which is, you can think of this as a maximum price. And then a price floor, as you can probably guess, is a minimum price. Now, why do they do this? Well, usually it involves politics. It isn't normally these movements do not make any economic sense. As you can see, they will end up being counterproductive. But politicians are politicians. They're responding to different factors than we are. As business people, we're trying to make money. We're trying to produce goods that people want. We're trying to keep people happy, and by doing so, keep our profits as high as we can. Politicians are trying to get reelected. And they may say and do things that will be economically counterproductive, and yet still gets them votes, and they may be then tempted to go ahead and do these things just because they'd rather be in power than not be in power. So we'll start with the case of the price ceiling. Now, the price ceiling is the limit a limit to the price at which you can sell a good. Now, you don't see so much of this anymore, but a perfect example of this is something called rent controllers, rent ceilings, where the government would actually come into a town and say, listen, the highest the rent can go is X dollars. That's it. You can't charge any more than that. Now, this kind of thing really got rolling during World War II when, a lot of consumer goods were no longer available because all the resources were being diverted to the war effort. So the governments were afraid that, well, when this happens, maybe landlords will take advantage of their tenants. So we'll set a limit on how much rent they can charge. Don't worry, we'll get rid of it after the war is over. And of course, they never got rid of it because, like I said, politicians can get elected by promoting this kind of thing. But the average person doesn't understand how destructive this really is. It sounds like, oh my God, the government is very helpfully putting a limit on my rent. But what is the ultimate effect of this? Well, let's start with this case. So we have an equilibrium in this market of $3,000 a month for the rent in this city, wherever they are. And at that price, 1,500 units are being rented. Okay, so everybody's happy. Everyone who wants an apartment has one, as long as they're willing to pay $3,000 for it. Now, the government comes along and says, oh no, from now on, you can only charge $2,000. Now, what this means then is that we're going to have a shortage. The price is too low. There's a shortage of 1,000 units. Unlike in a free market where the price would just go back up to its equilibrium level, it's not allowed to go up there. The law says now that you can't charge more than $2,000 for these units. So the shortage is now permanent. And in this context, shortage means people have no place to live. So you can see this is not a good thing, is it? Yeah, the lucky 1,000 who got to keep their apartments are happy because they're paying $2,000. But what about all the other people who have no place to live? I don't think they're too happy about this. And what about the landlords? What if this rent no longer is enough to cover their costs of maintenance? And this kind of thing did happen, like in New York City in the 70s. A lot of buildings were abandoned because of the rent controls that did not make it possible for the landlords to fix their buildings and make a profit. So a lot of buildings fell apart. They weren't maintained properly. There is a way by voting people out who try to do this kind of thing. That's really the only recourse we have, unless it's actually unconstitutional. So instead, we have to vote for politicians who would never be so stupid to impose rent control. But yeah, I mean, you would think that the landlord's property rights are being grotesquely violated and that would somehow be unconstitutional, but they've been able to get away with this for decades. But here's the good part about it. In many cases, what they've actually done is they've set it up so that once the tenants die or move out, then the rent control goes away. So this is only meant to last until the current tenants leave. And so in small stages, this has applied to progressively fewer and fewer homes. And so it's kind of taking care of itself in a way, but it caused a lot of issues for many, many decades. It caused a lot of disruptions. And, like the housing stock in New York City is certainly lower than it could have been had they not had this policy all those years. So, but yes, as long as it's in effect, there's going to be a permanent shortage. And then you also have the reality is you start ending up with people bribing landlords to let them move into an apartment. And so you end up with what are called black markets, where illegal activity takes place, which only increases the contempt for the law. And then it's just, let's just say it's not a good situation. So anyway, but this is what happens with a price ceiling. Now, sometimes you run into this with agricultural commodities. The government had traditionally interfered with agricultural markets. The motivation was to make sure the farmers had a certain minimum income, but eventually, like everything else the government does, it eventually became counterproductive. And so you end up with sugar farmers, even to this day, being paid large amounts of money not to grow sugar. to keep the price from falling. And who pays for that? The taxpayers, of course, and the consumers of sugar. But anyway, so that's a price ceiling. Now, here's the one that is currently in the news all the time. Let me jump ahead to this one. A price floor is the minimum price that which you're allowed to charge, pay for something. Well, the ultimate example of this is the minimum wage. Government comes along and says, listen, you must pay everybody, let's say it's $10 an hour. They're trying to push it up to 15, but let's say it's 10 right now. And they're saying, listen, if you want to hire people, you must pay them at least $10 an hour. Well, what's that going to accomplish? Well, let's look at the supply and demand curves. And let's just say we have that situation in this market. Now, this is, by the way, this is what we will call unskilled labor. These are jobs that anybody could do. This does not have anything to do with doctors and lawyers and economists and, you know, accountants. These are people who, let's say, are high school students who just want to work, people who have very poor skills that can really not realistically work anywhere else except maybe McDonald's. And so this is the market for unskilled labor, it's called. Basically jobs that anybody could do. And so at the moment, the equilibrium price is $8 an hour. At that wage, 1 million people are hired. So the government comes along and says, oh no, that's not enough. You have to pay them $10 an hour. Oh boy, look what happens. Well, at that wage, you've got 1.25 million people want to work, but the businesses can only afford to hire 500,000 people. So you have a surplus. And unfortunately, that surplus in this context means unemployment. You have a surplus of workers, people who have looking for jobs but can't get one. And this, of course, is now permanent. These people cannot work because they can't produce enough to generate a salary of $10 an hour. So they're stuck. What do? Where do they go? They can't find a job because whatever their skill set is, it's not enough to justify paying them $10 an hour. Now, you might notice before COVID got rolling, if you went to a McDonald's, let's say 2 years ago, a lot of them were starting to introduce these computer screens where you could order your food rather than go up to the counter and speak to a human being. What was the purpose of that? Well, yeah, they want to stay on top of the technology, but the machines were there to replace some of their labor because, you know, let's face it, labor is the most expensive input into the production process. And so McDonald's was trying to save money by having machines do some of the work of human beings. And by having politicians come along and say, no, we've got to pay people $15 an hour, all that would do is accelerate the trend towards using machines instead of people. And so unemployment will only go up. So that's what this is doing. Now, this one, unlike the rent ceilings, which are slowly disappearing, this one, if anything, is getting worse. The politicians are like, it's like they're almost competing with each other to have a more and more ludicrously high minimum wage. And so the only thing that this can do is put people out of work. Sure, some lucky people will get a higher wage, but look at these other people. They have no income at all. So the politicians don't seem to have an answer for that. But they feel like this gets them reelected. And so they go about campaigning about, oh, wow, look at me. I gave you a higher minimum wage. Don't think about those poor people who are out of work. Just vote me into office because I brought you a higher minimum wage. And that's how this happens. But anyway, so the bottom line here is that when the government intervenes in these markets, typically we end up with either a permanent surplus or shortage. In both cases, the effect is totally counterproductive. It may benefit a few people, but more people will end up being hurt. So the net effect is a loss to society. So we hope to see this kept at a minimum. The free markets are going to adjust themselves more efficiently than anything the government can ever do. So anyway, so I believe that's it for chapter 4. So that was a lot of material. So where there is a problem set here, let me go see if I can get it out and see what was in it. I think we're ready for it, but you may need some time to work on it. So I was thinking that what we could possibly do is go over this not on Tuesday, but on, yeah, here it is. Tuesday, but maybe Friday. Where is it? There it is. Okay. Oh my God. Yeah, I mean, it's not that long, but there's a lot of good questions. Yeah, there's only 4 questions, but this could take a while. So let's do this. Why don't you print it out and start looking at it? And if you have any questions, we can go over them on Tuesday, but then we'll go over them together on Friday just to make sure you're understanding this. Now, chapter 5, like I said, is our first chapter that's pure macroeconomics. So let's see what it is. It is all about gross domestic product. Okay, so think of gross domestic product as the value of all the goods and services that a country produces during a given year. It's a very important indication of how well the economy is doing. The faster it grows, the higher our living standards are. So this is a very important idea, and you do hear it discussed in the media all the time. So we'll go over this on Tuesday, and you'll start to recognize, you may have heard this discussion in the media. The focus here is on how quickly the economy is growing, specifically how fast is GDP growing. So ideally, it should grow at a steady rate, not too fast, because that starts to cause higher inflation, but not too slow, because that tends to lead to unemployment. So the job of policymakers in the government is to keep GDP growing steadily. We want it to grow at a certain rate. Like I said, not too fast, not too slow. But before we do that, we have to define it and understand what is actually included in this GDP measure. And we also want to understand how large it is. I'm going to tell you right now, the United States has by far the largest GDP in the world. Each year we produce roughly $20 trillion worth of goods and services. That's a lot. That's quite a lot. The next closest, I think, is China. They're around 14 trillion. And then I think the next after that might be, it might be Germany, maybe at 5 trillion. So we'll get into this next week. But remember, think of this as essentially national income. What are we producing? How much income do we have as a result? So this is, like I said, it'll be our first pure macro topic. And after this, it'll be all just 100% macro, but we'll lean on the concepts we did in the first 4 chapters as we go along. You can never completely separate out micro from macro. They're very tightly related to each other, but you can focus your attention on macro concepts here. And in another class, you would focus on, of course, micro concepts. So anyway, so if there's no last minute questions, I think we can get going. But remember, at least take a look at the problem set for 4, and maybe get some practice drawing the curves while you're at it. And then we can go over it on Friday. Okay, and Tuesday, we'll just carry on with chapter 5. All right. Fernando.
Could I ask you a question?
Yes.
After class?
Oh, yeah, when everyone's done. Now, I know nobody wants to leave because you're having so much fun. So we'll give it a minute. So everybody else, I'll see you on Tuesday.
Thanks, Professor.
Later. Bye. Bye. Thank you. Have a great weekend. Okay. All right. See, people don't want to go home. Okay. All right. Well, okay. Nobody wants to leave, do they? Do you want to send me a message by the chat room?
I could just ask real quick. It's fine.
All right, okay.
So it's a quick question about for pre-calculus class
Yeah.
with you. I
Yes.
want to ask, is there a way we can like increase our like the amount of like, can we increase the time for like, after like taking a break? Because I know we have a really long class for that, and it's kind
Oh,
of
the
hard.
break, you want a longer break?
Like maybe like a couple more minutes. Like,
Oh,
if
all
it
right,
does-
sure, it's fine with me.
I mean,
if
again, I
you-
don't know if it's just me, but I mean, or if it's other people as well. But it's kind of hard to continue focusing.
I know. Oh no, I don't think it's a good idea to have the whole class once a week either. But it really is the only thing that worked in everybody's schedules. And but you're right. I mean, if you think it's not a long enough break, just remind me on Wednesday, and I'll say, all right, well, it's because we do get a lot done in that class anyway, so we can certainly afford to spend another 10 minutes recuperating if that's what you need.
Sure. Thank you.
Okay,
Thank you,
just
sir. Have a
remind
great-
me. That's all.
Yeah, I will. Thank you, sir. Have a great weekend.
Okay. All right. Okay. Bye.
Bye.